Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. So for the audience may already know that I changed the channel name to be the Olympiad Geometry Club. It's just because if you search Olympiad Geometry on YouTube, you cannot find my channel. I think it's because when I created this channel, each channel has a handle, and at that time the Olympiad geometry handle was used by another channel, so I didn't understand what does handle mean at that time, so I just gave it an arbitrary name like Olympiad geometry 2024 because the channel was created in 2024. And because of that, so lots of audience told me that if they want to search my channel, they cannot find it. And I try to understand what's going on, and I finally got it. It's just because that handle. The Google search cannot match my channel to Olympiad Geometry, but the Olympiad Geometry 2024. So anyway, I changed the channel name to be the Olympiad Geometry Club. So if you search Olympiad Geometry Club, you can find my channel now. And for the handle Olympiad Geometry, it's being used by another channel, which is created by a Russian guy. I think he solved many great problems, but he's now speaking English, and I can only understand some of the problems, but I don't quite understand. I cannot get any really useful information from his channel. So I hope that my channel can bring different perspective of the geometry, and also can give the audience good and high quality problem solving, and also the knowledge based of the Olympiad geometry or the plane geometry. Okay, that's just a brief explanation for the name changing. Let's just continue our study. So here I will talk about the problem of the day 17, which is the Canada Olympiad math computation training in 1988. It's a pretty old problem, but it's a very interesting problem. The inner angles ratio of a triangle is 1 to 2 to 4. That's a problem set. Prove that the intersection points of angle bisectors and the opposite sides form an isosceles triangle. So we already know the summation of the inner angles of a triangle is 180 degrees, which we can represent it by pi. So for this one, we already know that three angles has a ratio as 1 to 2 to 4, which means the angles would be pi by 7 to 2 pi by 7 to 4 pi by 7, right? Then we can draw this. We know that this is larger than half of pi, right? So we know that this is larger than 90 degrees. Then we can just draw it like. So pi is 180 degree to 7. That's roughly say 25, 26 degrees, right? So this probably 30, so we draw it a little bit less than 8 here, and for here we need to draw it like 50 degree, right? So this is about 60, it's roughly about 50. It's just a feeling of it, right? Okay, and it form a angle a little bit larger than 90 degrees. Okay, then we can give the name as A, B, C here, and we know that angle A is pi by, this one is pi by 7, This one is 2 pi by 7. This one is 4 pi by 7, right? And we want to prove that the intersection points of angle bisectors and the opposite sides form an isosceles triangle. So we can just find the angle bisector of this one, angle bisector of this one, and angle bisector of this one, right? So now we have this angle, that's 2 pi by 7. This one is 2 pi by 7, right? So I'm going to zoom in this a little bit because we basically just work on this figure, okay? We have 2 pi by 7 here, 2 pi by 7 here. And we know that because we draw the angle bisector here, so for this one, it's pi by, this one is pi by 7. This one is pi by 7. And for each of these now, this one here, it's pi by 14, right? And this one, it's pi by 14 too. Right, so let's just consider it as theta. So let's make pi by 14 equals to theta, right? Then we have theta here, theta here. This one, that is 2 theta. And this one is 2 theta, right? This one here, that is 4 theta. This one is 4 theta. Right, so we know that 1, 2, 3, 4, 5, 6 plus 8, that's 14, right? 14 theta equals 2 pi. Okay, now we want to prove this is the intersection point of the angle bisectors with the opposite sides, right? We want to prove this triangle DEF is an isosceles triangle. So we want to prove that triangle DEF is an isosceles triangle, which means that we want to find two sides of the triangle DEF are equal, right? So if you look at this problem, you know that we have to find a way to add auxiliary line here to help us to solve the problem, because just based on this thing, we cannot get the angle of these or the edge relation here. So the easiest angle that we can think of is to find the angle bisector of the angle EBA. Why we want to do that? Because we have theta here, we have theta here. If we just find the angle bisector here, then we basically form. So first thing is that we find the in-center of the triangle EAB. Also, we can form another isosceles triangle here, right? So it might be useful, but we don't know. We can just try it here. Now let's look at this one. Maybe I'm trying to get it to as correct as possible. Right, okay, that's a line here. Let's call it BG, okay? So BG is the angle bisector of angle EBA. Make this angle, so this one now is theta, this one now is theta, right? So we have theta, theta, 2 theta, 4 theta, 4 theta, 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 right? That's the angles. Now we look at here, this is 4 theta. This is theta, this is theta. That means the angle CFB equals to 4 theta plus 2 theta, which is 6 theta, right? The angle CFB FB is 6 theta. And angle FBG is 1 theta. Let's call this point as J, okay? That means angle BJF equals to 7 theta, right? Because the summation of the inner angles of a triangle is 14 theta. We have 6 theta here, 1 theta here. So that means this angle must be 14 minus 6 minus 1, which is 7 theta, right? This is 7 theta, which means angle BJF is 90 degrees, right? This is 90 degrees. Okay, now let's think about this one. We have 90 degrees here, and which is 7 theta. So this is 7 theta, this is 4 theta. That means the angle CGB or angle CGJ is 3 theta, right? CGJ equals to 3 theta. And angle CBJ is 3 theta. Which means the triangle CGB is an isosceles triangle. So CG equals to CB. Okay, CG equals to CB. And let's look at the CE part. Okay, let's look at the CE part. Here, this one is 4 theta, right? This one is 4 theta, this one is 4 theta, and this one is 4 theta. So we know that this one is 4 theta, and this is 4 theta. So we know that CF equals to FB. Right, CF equals to FB, and CG equals to CB. CF, let me just rephrase it again. CF equals to FB, and CG equals to CB. Remember that we want to prove the triangle EFD is an isosceles triangle. So we want to find the CE and FD part. Right? We want to find CE and FD part. Okay, now let's look at CD. Okay, let's look at CD. This is 4 theta. And what's this angle? This angle equals to this angle, right? And this angle, the angle CDA equals to, because this is 4 theta, this is 4 theta, that's 8 theta, this is 1 theta, so the total is 9 theta, which means the angle CDJ or angle CDA equals to 5 theta, right? 14 minus 9, that's 5 theta. And because this is 5 theta, this is 4 theta, so the total is 9 theta. That means the angle CJD equals to 5 theta. Right? That means CD equals to CG. CD equals to CJ. And we already know that angle JFB is 6 theta. Here angle JBF is 2 theta. So the total is 8 theta, which means the angle, this one is 6 theta. So here the angle BJF is 6 theta as well. That means the angle EJC equals to angle BJ. Sorry, no, this is not J. This is I. The angle BIF equals to angle BFI equals to 6 theta. And angle CIE also 6 theta, which means the angle CEI is 4 theta, right? So angle CEI equals to 4 theta. That means here is 4 theta, this one is 4 theta, EI equals to CI. Here should be I, not J. Let me rephrase this part. The CID equals to 5 theta. I'm sorry here. So let's see here. The angle CDA, this angle is 5 theta, right? Because the total would be 14 theta minus 8 theta minus 1 theta. That's 5 theta here. And in triangle CID, this is 4 theta, this is 5 theta. So this one should be 5 theta, right? That means CD equals to CI. CD equals to CI. And in the triangle CIE, this angle equals to this one equals to this one, right? Because this is a angle bisector and it's perpendicular to IF. So the triangle IFB is an isosceles triangle, which means the angle FIB equals to angle IFB equals to 6 theta. So this is 6 theta, this is 4 theta. That means this angle, the angle CEI is 4 theta. So this is 4 theta, that means CI equals to EI. So we can see here CD equals to CI, CD equals to CI, CI equals to EI, right? CI equals to EI. And now let's consider connect GI. We connect the GI here. So if you look at this angle, the angle GEI, the angle GEI equals to this one plus this one. That is 10 theta, right? The angle GEI equals to 10 theta, which means this angle plus this angle is 4 theta. And remember that we learned about this before. The triangle EAB, the triangle EAB is an isosceles triangle, right? Because this is 2 theta, this is 2 theta, this is 2 theta, right? Here, the angle EBA is 2 theta, the angle EAB is 2 theta. So AI is an angle bisector of angle EAB, and BG is an angle bisector of angle EBA. That means GI is in parallel with AB, right? GI is in parallel with AB. This can be easily proved, right? Just because this is theta, this is 3 theta, so we know that this angle is 11 theta. Similarly, this angle is 11 theta. So these 4 points, the G, A, B, I, are cyclic, right? G, A, B are cyclic, which we can easily calculate just because they are cyclic. So the angle G, I, B is 12 theta, which plus 2 theta is also pi. So that means GI is in parallel with AB, right? GI is in parallel with AB. That means angle EIG equals to angle EGI equals to angle EAB, and angle EBA equals to 2 theta, right? That means EG equals to EI. Okay, now look at the relation we got here. We know that CD equals to CI, and CI equals to EI, and EI equals to EG, which means CD equals to EG. And we already know that CG equals to CB. So CB, let me write it down here. We know that CD equals to EG, and we know CB equals to CG. So CG minus EG equals to CB minus CD, right? CG minus EG, that is CE, equals to CB minus CD, that is DB. Now we know CE equals to DB, and angle ECF equals to angle DBF equals to 4 theta. And we already know that CF equals to FB, which means triangle CEF is congruent to triangle BDF, right? That means that means CF equals to BF, right? CF equals to, EF equals to FD. EF equals to FD. Right, that means EF equals to FD, which means the triangle EFD is an isosceles triangle. Okay, so this problem is not a very easy problem. The difficult part is that you have to figure out the auxiliary line, and based on the auxiliary line, you have the sense that this auxiliary line helps us to find a parallel line GI to AB here. And based on the parallel line, you know that GE equals to EI. And also you already noticed that CG equals to CB. So you want to know whether EI equals to a segment here, then you need to calculate all of these angles, okay? I think for nowadays, it's not a difficult problem on the IMO level or even on the national level, but it's still definitely a problem on the state level. So I hope you like this video. Hope you like this, enjoy this problem. See you in next one. Thank you.